Statistics is often hailed as one of the most useful areas of mathematics. It helps us to make educated guesses of the unknown and find useful information in an ocean of data. But despite its usefulness, many people struggle with statistics. What is it? How does it work? For many, statistics feels like an unending collection of rules and formulas. Even worse, if it's misapplied, statistics can lead to false conclusions. This causes some people to develop a mistrust in the subject altogether. So, what is it all about then? Well, statistics is the area of mathematics which primarily deals with collecting and analyzing data. Some great examples might be keeping track of your favorite team as they rack up wins and losses, or perhaps using data to try and predict the outcome of an election.
Statistics simply means numerical data and is field of math that generally deals with collection of data, tabulation, and interpretation of numerical data. It is actually a form of mathematical analysis that uses different quantitative models to produce a set of experimental data or studies of real life. Two branches of statistics. The two major areas of statistics are known as descriptive statistics, which is describe the properties of sample of population data, and the inferential statistics, which uses the properties to test hypotheses and draw conclusion. Descriptive statistics are brief, informational, efficient that summarize a given data set, which can be either a representation of the entire population or a sample of a population. Descriptive statistics are broken down into measure of central tendency and measure of variability. The statistical inference is the process of using data analysis to infer properties of an underlying distribution of probability. Inferential statistical analysis infers properties of a population, for example, by testing hypotheses and deriving estimates.
From which draw data for statistical study. It can be a group of individuals, a set of items, and etc. It makes up the data pool for a study. Generally, population refers to the people who live in a particular area at a specific time. But in statistic, population refers to the data on your study of interest. It can be a group of individuals, objects, events, organization, and etc. You use population to draw conclusion. An example of population would be the entire student body at a school. It could contain all the students who study in the school at the time of data collection. Depending on the problem statement, the data from each of the students is collected. Examples is the students who speak Hindi among the students of a school. How to collect data from a population? You collect data from a population when your research question needs an extensive amount of data or information about every member of the population is available. You use population data when the data pool is a small cooperative to give all the requirement information. For a larger population, you use sampling to represent parts of the population from which it is hard to collect data. An example of data collection over a small population is the analysis of the end of the year marks. The school needs to collect the marks of all students, analyze their students' overall performance. As they only need to do it for students in their school, they can use the entire population. So set also something. What is sample? A sample is defined as a smaller and more manageable representation of a larger group, a subset of a larger population that contains characteristic of the population. A sample is used in statistical testing if the population size is too large for all members or observation to be included in the rest. The sample is an unbiased subject of the population that best represents the whole data. To overcome the restraints of population, you can sometimes collect data from a subset of your population and then consider it as a general norm. You collect the subset information from the group who have taken part in the study, making the data reliable. The results obtained for different groups who took part in the study can be exploited to generalize for the population. Tay.
Okay.
The process of collecting data from a small subsection of the population and then using it to generalize over the entire called sample. The data collected is not reliable. Ay, sa kuno ikat sa kuno.
Okay.
A sample should generally satisfy all different variation present in the population as well as a defined selection criterion. Be utterly unbiased on the properties of the objects being selected. Be random to choose the objects of study fairly. Say you are looking for a job in the IT sector. So you search online for IT jobs. The first search should be for jobs all around the world, but you want to work in India. You should search for IT jobs in India. This will be your population. It will be impossible to go through and apply for a position in the listing. So you consider the top 30 jobs you are qualified for and satisfied with and apply for those. These are your sample. Sa equal. Difference between population and sample. Population. All residents of the country will constitute the population set. Sample. All residents would live above the poverty line would be the sample. Ay, turo. Tay.
Ha?
Turo.
Tanan?
Ay, ipus. Talaga na?
Okay.
Population. All residents of the country will constitute the population set. All residents above the poverty line in a country would be the population. All employees in an office would be the population. Sample. All residents who live above the poverty line would be the sample. All residents who are millionaires would make up the sample. Out of the employees, all managers in the office would be the sample.
Parameter versus statistic. There are the differences. The difference between a parameter versus statistic is that a parameter is a fixed measure describing the whole population, while a statistic is a characteristic of a sample of portion for the target population. A parameter is a fixed unknown numerical value, while the statistic is a known number and the variable which different on the portion of population. Sample statistics and population parameter have a different statistical notation. Example of parameter: 20% of US senators voted for a specific measure. Since there are only 100 senators, you can count what each of them voted. Example of statistic: 50% people living in the US agree with the latest health care proposal. Researchers can ask hundreds of millions of people if they agree. So they take samples of part of population and calculate the rest. Parameter in statistics, both are similar yet different measure. First, one describing the whole population, while the second describe a part of the population. That's all.
Two types of data in statistics. The data types and sources. So collecting go data is the foundation on which you gather evidence and make sense of it. Besides what data make you need when you design your project, then you can gather the right information from the start and throughout the project. There are two general types of data, the quantitative and the qualitative. And both are equally important. So importante kini sila sa when we talk about statistics. You use both types to demonstrate effectiveness, importance, or value. So mayingon tag quantitative data. Quantitative data is information that you can measure. Each number is something you can count because it is quantifiable. It can be reliable in evidence. Evidence example include how many people took part. Example in ang program pila kabuk mga apil pila ni participate. How much did it cost? Pila na gasto. How long did it run? Sa kadugay. Human ng yung sa inyong gibuhat na program makaka average attendance at each program session. Mga different kon. Ano nang mga dagang lain nga mga program mga kon pila kabuok ng attend, pila kabuok ni participate. Muna siya ang quantitative. So, ma-count nimo siya, countable. Understand? While qualitative data is information about qualities, you can count it. That it is information about how people about something sample include. Sharing what people like about the program. Kung unsay ka nang naang gayana ka na magsilbing first impression ug feedback nila ba mga inana. What difference it has made to their lives. Whether they would recommend the program to others or not. Kanang inana ba nga on. So quantitative sources. Mga example sa quantitative resources. Program information, numbers involve what happens when ug hadapit. Then sa qualitative data resources, getting feedback on a program, weekly check in surveys, handa kag mga surveys, then ang mga result ato mga feedback nila. Samo na to after program questions. So come up ka ng mga inana ang sa qualitative after questions mag-survey ka magatag mga questionnaire baka diha. So mara to
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Nominal, ordinal, interval, and ratio data. Going from lowest to highest, the four levels of measurement are cumulative. This means that they each take on the properties of lowest level and add new properties. Why are levels of measurement important? The level at which you measure a variable means how you can analyze your data. So the different levels limit which descriptive statistic you can use to get an overall summary of your data, and which type of inferential statistic you can perform on your data to support or refute your hypothesis. In many cases, your variable can be measured at different levels. So you can have to choose the level of measurement you will use before data collection begins. So this is the example of ratio skills. You can categorize rank and inter-equal intervals between neighboring data points, and there is a true 0 point. A true zero means there is an absence of the variable of interest. In ratio scales, 0 does mean an absolute lack of a variable. For example, in the Kelvin temperature scale, there are no negative degrees of temperature. 0 means an absolute lack of thermal energy. So, you can categorize rank and inter-equal intervals between neighboring data point, but this is no. So, ibalik na nako. So, the difference between any two adjacent temperatures is the same, 1 degree but 0 degree, and defined differently. Depending on the scale, it doesn't mean an absolute absence of temperature. The same is true for test score and personality distress. A0 to a test is arbitrary. It does not mean that the test taker has an absolute lack of the trait being measured. Although you can rank the top 5 Olympic medalists, this skill does not tell you how close or far apart they are in number wins.